Sorry for the inconvenience. So I'll again read the question. So in the SU3 quark model, you have triplet of mesons. So you need to find out the isospin and its strangeness of these mesons. So you know very well that hadrons are classified into two categories: baryons and mesons. They are further classified into two categories. Same goes for baryons. This is baryons and baryons resonance. The other one is pseudoscalar mesons and vector mesons. Okay, so they are fermions and they are bosons, right? Now, baryons are made up of three quark, either three quark or anti quark. Okay, but mesons are made up of one quark and one anti quark. Okay, so now they are asking to find out the isospin of these mesons. So they are like, you need to know how to tackle this, how to deal with this question. So now isospin. So I told you, like, if suppose you have neutron or proton. Suppose there is one system. In this system, electromagnetic field is absent. Okay? And you know very well that neutron and proton both have almost same mass. So how to distinguish between these two entity? So same way, like neutron or proton, these neutron or proton you have, or when you have triplet like these. So to distinguish between these triplets or these neutron and proton, you need to have some quantity, and this quantity is defined by isospin, right? And the component of isospin along the z-axis is Iz. Here in this question, so three particles are there, right? So the multiplicity is 3, and there is one formula: m is equals to 2I plus 1, and this m define how many particles are there. So there are three particles, so that means 3 is equals to 2I plus 1. Okay, so 2 is equals to 2I, I is equals to 1. So isospin is 1, so this one is correct. But if suppose you need to find out the strangeness, huh? So there is one formula, that is Gelman Nishiji formula. Nishiji formula. So it says Q is equals to I Z plus B plus S by 2. So we know the answer is B because we have found out the isospin. But if suppose someone wants to know the strangeness also of all these particles, so this is just add on. So Q is the charge. Iz is the third component, the component of isospin along the z direction. B is baryon number. S is strangeness. Okay, so you know they are mesons. So they all have baryon number is equals to 0, right? And one more thing is, so now you got I is equals to 1. So Iz will vary from minus I to I. Okay, so that means Iz will vary from minus 1 to 1. That means minus 1, 0, 1. So pi, pi positive will have I is equals to 1 and Iz is equals to 1. And pi 0 will have I is equals to 1. I will remain same for all this. I will remain the same. Even for neutron or proton also, I will remain the same. Only Iz varies. And Iz is equals to 0, and for pi negative is equals to I is equals to 1 and Iz is equals to minus 1. Now do find out the strangeness of all these particles, of all three particles. So first I'll go for pi positive. So Q is equals to 1. I'm putting all this value in this formula, huh? So Q is equals to 1 and Iz is equals to 1 plus baryon number is 0 plus S by 2. This 1 and 1 will give 0. S by 2 is equals to 0. So S is equals to 0. Okay. Now I am going to find it out for pi 0. So you know for pi 0 charge is 0, Iz is 0, baryon number is 0, spin you need to find out. So S is 0. Similarly, if I'm telling you to do it for pi negative, so pi negative, Q is minus 1, Iz is minus 1, baryon number is 0, so S by 2. So S by 2 is equals to 0, so S is equals to 0. So the answer is isospin is 1 and strangeness is equals to 0. Okay. I hope this question is clear to everyone because this question was straightforward. So you need to find out the isospin. So isospin has this formula m is equals to 2I plus 1. Keep that formula in mind, huh? So m is how many particles are there. So if this is a triplet, so that means m is equals to 3. So suppose you are given doublet like n or p. So m will, in the case of neutron or proton, your m will have 2 as its value. Okay, and then 2I plus 1, from that you will get I, and you know Iz value varies from minus I to I. So Iz will vary from minus 1 to 1. So you will find out the I and Iz value for each triplet, and from that put the values in Gerelman-Nishija formula. You will get the strangeness of each particle. I hope this question was quite straightforward, just formula, putting values in formula. So I am going for the next question. Okay. Now this question, I hope again this question came for 1 marks. So I want all of you to at least try this question. I mean, I'm giving you 2 minutes. You can try this question. This question is quite straightforward. Just try this question and tell me why the B will be the answer of this question. Correct. So in this question, see, manganese is given to us. Hmm? And yes, electron neutrino is the correct answer. The reason being, ha, yes, correct. So, first of all, you need to find out this x. So, you know, in this, in left hand side, electron is given to us. So, electron is a lepton. And lepton, there are 6 lepton. Electron, electron neutrino. Muon, muon neutrino. Tyon, and tyon neutrino. Okay. They all have lepton number is equals to 1. So this is the fundamental quantity. This lepton number, charge, baryon number, isospin, strangeness, parity. These are some quantity, and it's not parity, not parity. So this lepton number, baryon number, these are some quantity that needs to be conserved. If you are looking for any reaction to proceed, then these need to be conserved, right? So here the lepton number is plus 1. So here also it should be plus 1, right? So electron neutrino will be the answer. Now everything is balanced. Charge is also balanced. uh, mass number is also balanced. Atomic number is also balanced. So everything is balanced here. So B will be the answer. Good that everyone has done this question by their own. So it's really nice. So moving on to the next question. Now this question you are asked. I'm again giving you 2 to 3 minutes to solve this question. This is also quite a straightforward question. Okay, okay. Okay, so this question you have solved this question. So in another NPTEL class, right? Okay, okay, okay. So then for you, I mean, it's quite easy, like piece of cake. Anyways, for those who have not done this question, so I'll give you polyspin matrices. This you should know, huh? Polyspin matrices. What is a delta x, delta y, and delta z value? Because these I have seen like pattern of gate examination. I've seen like one question from polyspin matrices generally come like one question all the time. I've gone through all the previous year papers and I've seen one question from polyspin matrices. In fact, in 2021 or this 2021 in 2022 this year also one question from polyspin matrices came to the examination. So this is quite uh, like this topic from this topic at least one question is generally coming in examination, so you should know the value of delta x, delta y. Okay, so this is I have given you the value of delta x, delta z, and delta y. So, sorry, sorry, sigma x, sigma y, and sigma z value. So you just put these values in expression and tell me what is the answer, all of you, because you should know these value. Once you are aware with all these value of these matrices, sigma x, sigma y, sigma z, then this question is very easy. So just try to put it so that you'll yes. Okay. Which question? Okay. Hmm. Hmm. Okay. Hmm. Hmm. There is one question like that. I know which question you are talking about. So just post this question in chat. I'll take this question in the next class. I know which question you are talking about. You are given you are given the value in z direction, so you need to find out in the x direction, right? Ha ha ha. Sure. Or otherwise, I'll forward you the solution of it to you. Okay, okay. Sure, 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 sure. You just put that question in chat so that I can have a look at this question. Others, are you done with this question? So what is the answer? I sigma z. So yeah, so the question was straightforward. Sorry, 0, 1. But you should know this value, huh? Sometime in examination, mugging up a lot of formulas and value. We just forget all these values. So this is kind of a disadvantage. So your memorizing power should also be sharp. This is iota, and this will give 0, 0, 0, and no, no, this is minus iota. Then this is 0, minus 1, and this one will be 1, 0, 0. And now 2 iota. I think I'm doing something wrong. 0 iota minus. No, no. Wait. Sorry, everyone. 0 iota 0, 0, 1, 1, 0. Right? 0 minus iota is will come here. This one will be 0, 0. This one will be 0, 0, and this one will be iota. So this will become iota 0, 0 minus eta. So I will come outside 1, 0, 0 minus 1. So this will be I sigma z, right? This one will be the answer. Okay, I hope everyone have done this question. Now this question again, I want all of you. Ha ha ha. Yes. Ha ha. See. Okay, your voice is breaking. Yes. Huh. Do you have any? Then let me do it. Where is pen? Then if it is minus, suppose this is minus. So what would be the answer? So this will be 2 iota minus. This is minus, na? Wait. This will be 3 iota 0, and this is 0, and this will be minus 2 iota. Then there won't be anything. I mean, no, no, no. Minus 3 iota, right? Minus 3 iota. So you will take 3 iota outside, 1, 0, 0, minus 1. So this will be 3 I sigma z. This would have been the answer. This one. If suppose it was given like this, so this would have been the answer. Okay? Okay. Now moving on to this question. Haha. Before this. Okay. Huh. Hmm. Hmm. No, 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 no. No, no, no. You are taking it wrong. I mean, this is 25, na? This is manganese. So from this electron, we generally denote it like this. Minus 1 is 0. So your mass number, atomic number is always decided by proton, not by electron. So this 25 is number of proton. It is always decided by number of proton, atomic number. So this will be balanced. Like if I write this equation, so suppose I'm writing this equation. So I'll write this equation like this: 54 plus minus 1 is 0, 24 chromium, 24. This is generally we denote it. So like 25 minus 1 is 24. Yep. Hmm. So no, no, no. Only take lepton number. Only take of this one. Neutrino, yeah, neutrino is a chargeless particle, so it is balanced, right? So here there is 25 minus 1 is equals to 24 electron. So here also 24 electrons. So it is balanced on both sides. So neutrino is chargeless. Hmm. Mhm. Okay, let me think about this question. So you have 25 manganese, 54 plus 24 chromium plus X. So this electron will have charge. So suppose this manganese. I'll take this question later in the class, or maybe in the next, or maybe in the next class, because okay. So this question and the other one which the boy was asking. So these two questions. Coming back to this GATE 2015 question. So this again, this question, I think you guys can try this question again. So and give you the value L is equals to R cross P X Y Z X Y Z px. So this orbital angular momentum and linear momentum has this relation, and L and P be the angular and linear momentum. Okay, these are the operators for a particle. Suppose we have one particle and there's our operator. So the commutator, this commutator, you need to find out the value of this commutator. So I hope, sorry, this is, you need to find out x, right? The angular momentum operator along x direction. So this will be the value of this. X is equals to y pz minus z py. So the Lx will have value y pz minus z py. Okay. Now you need to find out y y pz minus z py comma py. I hope, I want again you, all of you, to try this again. This again a straightforward question. So this will become y pz comma py minus z py py. So now try this. Find out the value of these two. You'll get the answer. Any one of you got the answer? It's okay, I'll do. So here you can see this is ypz comma py. Hmm? So this you can write ypz. First it is commuting with py. Sorry, first this py is commuting with pz, and now second this is commuting with pz, not with sorry, this is commuting with y, and bz will remain outside. Okay. Similarly, you can write it like this. Then Z py and this py. I hope so you are well aware with the commutator relation, these relation. X px is equals to eta h cross, right? So this relation comes from here. So suppose you have x px minus px x, and it is commutating. We have taken some mistake. Okay, now do this solution. X px, you know, you can write px minus eta h cross dy dx, right? Again here minus eta h cross dy dx px and x. It's should be sine, right? And this is sine, yeah. So this is minus x eta h cross d psi by dx plus eta h cross. So first it will go differentiation. This one, this term will give 1. So this is directly sine plus plus eta h cross d by dx sine, and x will remain outside. So these two term will cancel and it will give eta h cross sine. So if you see the commutator relation of where it is, so x px psi is equals to eta h cross psi, right? So that means x px, the relationship between x and p along x direction is eta h cross. So here you can see this is 0 clearly, and z comma py also 0. These relations, these are commutator relations. This is also 0. So only ypy, zpz, xpx has value is equals to eta h cross. Others are 0, right? If you have x pz, this is 0. You have y pz, this is 0. Now here if you will come, you will again find this is 0. This is again commutator relation. This is 0. Now yz and py, which one is this? Is not pzpy. Sorry, this is py. Sorry, ypy, huh? Ypy is eta h cross, and outside it is pz. So that means answer is this one. I hope this one is clear for you, clear to all of you. This is nothing, just a simple mathematics, like how commutator relationship works. So you know, if you know this formula, so things, other things will become quite easy if you know this formula, this x and some other commutator relations also. Like you cannot have z px is equals to eta h cross. No, it is wrong. The value of it is 0. So these are some commutator relations, and this commutator relation you will find out means they are nicely given in. There is one book Zetli for quantum mechanics. They are nicely given in that. So I hope this question is clear to everyone. So shall I move to the last question of this question? Again, at least all of you at least give a try to this question and then tell me why the B option is not correct. At least give a try, huh? Huh. Say. Uh, am I audible? Oh, okay. So now, actually, I'm telling you that this question, all of you at least give a try for this question and tell me why B is not a correct statement for parity operator. No, B is a parity operator. Sorry. Mhm. Huh. Hmm. So these are operators. So these are all operator are Hermitian operator. So Hermitian operator. So it has property like it has real eigenvalue, Hermitian operator. The eigenvalues of Hermitian operator are real, and A dagger is equals to A. This is a property of Hermitian operator, and we know that all the operator that we deals with quantum mechanics are Hermitian operator. So this thing is correct. So if someone is looking at this question and he doesn't know he is not aware with quantum mechanics so much, but even if he knows that any operator in quantum mechanics is Hermitian, so he will be like, okay, this is correct. So now coming back to these other options, like these options. So parity operator is just a space inversion about origin. So you have this P, this is operating on some state. Huh? This, yes, yes. Can- huh. So this thing is also correct. If you are operating your parity operator on a wave function twice, that means you'll get the same wave function, and this will be identity operator. I was about to tell you the same. Like if you are operating it on state, so this will be like this, right? If you are again operating it on the same state, you'll get back with the reversal of coordinates, you'll get back the same state, that means I. So this is also true, right? So p square is giving you I, it is not giving you p square is equals to minus p, so that means this B option is wrong. If you want to verify this, so this is very easy. So p square is I, right? Both side do p inverse. Can I write it like this? And pa, in 12th and all, when we used to study determinant, so there was one thing like A inverse is equals to I, A inverse A is equals to I, identity matrix. So this is I, so P is equals to P inverse. This question was quite straightforward. If you would have known like P square is equals to I, so then you can easily make find out that this is the wrong option. So I hope this question is clear to everyone. Now coming back to the boy and a girl question, like one boy was asking question. Huh. Hello. Huh, huh. Okay. Yes. Yes. Hello. Can you repeat it? Huh. Huh. Yes. Say. Can you can your voice is breaking? Okay. 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 Okay, okay. I'll again explain. No problem. So this is the parity operator, huh? So you need to find out which statement is not true. Okay. So in parity operator, if you are reading parity operator or any operator in quantum mechanics, so they are basically Hermitian operator. So Hermitian operator are those operator whose eigenvalues are real, and they have this property A dagger is equals to A. So here you can easily see that parity P dagger should be equal to P. So that means this option is correct. Okay. Now coming back to all these three options. Now coming back to these three options. So parity operator is just sorry, space reversal, space inversion around origin. You are replacing xyz coordinates with minus x, minus y, and minus z. So now I'm applying parity operator on this sine state. So I am getting sine is equals to sine minus x, because it's just a space inversion. So again, if you are applying again parity operator on this state, you will get the same state again. You will get back the same state from which you have started. Like, hmm. So okay, so that means p square is equals to I, right? So this is correct. If p square is equals to I, so definitely p square is equals to minus p is not correct. So this one is the not correct option. And this I told you how to find out p dagger is equals to p inverse. Since you know that p square is equals to I, So you can multiply P inverse on both sides like this. So this will give you I identity. So P is equals to I P inverse. Okay, sorry. Wait. P is equals to P dagger, right? P is equals to P dagger for parity. So P dagger is equals to P inverse. Right? I hope this question is clear to you. Okay, okay then. Then only these property because I have read only these three properties. P is equals to minus P, like this way. But how P is equals to minus P? I mean, what is this mathematical significance of this statement? P is equals to minus P. I mean, so P is operating on psi, so it will give minus. Sorry, it will give psi minus x. I don't know. There is any such property. No, this will not be any property. Okay, your question. Uh, Hello. P. P is equals to, yeah. P is exactly P is equals to P transpose. ये P dagger or transpose. Sorry, transpose. What you are saying? It should be like this. It shouldn't be P is equals to minus P. So this is wrong. Hello. Am I audible? Hello. Okay. So can I come to? You have posted the question in chat. Okay. Let me have a look. Huh. Okay. I'm ending this. Mm. Okay. Now I can see your question. Option B is correct. Okay. Shantu Nath has done this question correct. Then yes. Okay. This is the question. Okay. For a spin S particle in the eigenbasis S square S Z, the expectation value of these are required to find out. And you are given this value gate 2010 question. Yeah, I'll do this question. I mean, yeah. I mean, this is gate 2010 question, na? So, okay, I'll do this question in the next class. I guess this is quite easy since, hmm, okay, S square and SZ. Wait, let me see. First of all, let me go here. Stop presenting. Okay. S square and SZ, right? Mm. Mhm. So you were given for spin as particle in the eigenbasis has given S square. SZ, the expectation value of is this. Hello. हाँ हाँ हाँ. Hmm. X square, you will write x, x. So you have this sigma x. So you know the relationship between sx and sigma x. So sx, can I go? So sx is equals to h cross by 2 sigma x. So what you will do? So you will write the expectation value of x. Sx is equals to h cross. Okay, I don't, wait. Let me do. So this state is given. Hmm. So this question is, sz is the expectation value of this one. So you need to for spin what x6, huh? Hmm. Sz is mh cross, yeah. Huh. Sz is mh cross. S square x, the x sx is equals to h cross by 2, and this sigma x value. Then you need to take okay, where, let me go. Okay. This one is particular eigenvalues, sz की expectation value. So this will be like this, na? I'm doing. Wait. The partition eigenbasis of s square. H cross 4 0 1. What is the answer for this one? I'm getting very weird answer. Option A. I'm getting very weird answer like 0. So since I have written Sx is equals to h cross by 2 0 1 1 0. Oh wait. I have not done 6. Can you share your screen? Okay. Okay. No problem. No problem. You can tell your what you have done. Hmm. Hmm. Okay. Hmm. Hmm. Yeah. As it. Yeah. I'll take this question in the next class, obviously. So because some confusion is still around, so I hope so. I'll do this question in the next class. Okay. Okay, everyone. Huh. Okay. Okay. Sure. Sure. What? Hello. X S, because s square is equals to sz square plus sx square s. Z square. So let's see. Hello. Hmm. Hmm. Okay. If you guys have made the Telegram group, you can share your answer to others so that other will also get to know what is the answer and how you have done it, your approach. So it will be helpful for others also, those who are preparing for GATE. So I'll take this question and one more question which the girl asked. So for the next class. So I hope we are coming to the end. So thank you everyone for joining the class. Potential step is the change in the potential, right? This is the quantum mechanics concept. So suppose, wave function, yeah, wave function is, suppose your particle is coming like this. Okay, I have stopped sharing my screen. Otherwise, I would have drawn everything. So kind of a step because there is a change in the environment, right? Earlier the particle is moving at zero potential, v is equals to zero. Suddenly it is experiencing a potential v is equals to v naught, so there will be a change in, like, change in the energy also. So also you are writing that for the first, there are two cases: when the particle is on left hand side, when the potential is zero. So at that case, Schrodinger equation will be minus h cross square upon 2m d2 psi by dx square plus v is zero. So, huh. Wave function that I have to solve a lot, or otherwise wave function, if you are telling for step potential, so it is wave function. But there are cases, right, when E is equals to E is less than V naught and E is greater than V naught. So when E is greater than, energy is greater than V naught, so it will pass the potential barrier because energy is greater than V naught. When E is less than V naught, then there will be tunneling, right? Because classical mechanics says that particle won't be on the right hand side, but quantum mechanically particle will be there. So there will be the cases when E is greater than V naught and E is less than V naught. So by boundary condition, we will get the values. So what you exactly want? Hmm. हाँ, 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 वेव फंक्शन, हाँ, वेव फंक्शन, okay, simply for which, okay, for E is less than V naught, na? For E is less than V, you have sinusoidal wave function on left hand side, okay, but on right hand side, the wavelength will increase. Wavelength will increase. Why? Wavelength will increase because momentum will decrease, na? Kinetic energy will decrease. So earlier particle has more kinetic energy than this side. So when particle will arrive at right hand side, so the kinetic energy will decrease. So momentum will decrease. So in a way, wave function, oh sorry, wavelength will increase. So you will have, there will be a spread, not spread. Spread is not correct word. So earlier this E less than V naught. Okay, sorry. E greater than V naught. E greater than V naught. Correct, correct. Hmm. So for other case, yeah, the particle will, there will be like constant line. I was talking about E greater than V naught, case E greater than V naught. For E less than V naught case, there will be a decaying function. For E less than V naught, there will be a decaying function on right hand side, because that will decay. The probability of finding the particle on the right hand side will decay. So there will be an exponential decay on right hand side for E less than V naught. For E greater than V naught, you will have, so you will have like sinusoidal kind of a wave function with an increase in wavelength because kinetic energy has decreased. Okay. Okay, then I'll finish this meeting and I'll take these two questions for the next. Okay. Okay, no problem, no problem. Next class, yeah, some gate questions like previous year, 1 and 2. Okay, okay, huh? Okay, okay, okay. No problem, no problem. Mm. Okay, no problem. Okay, okay. Now I am taking these two topic, beta decay transition and particle physics. So I'll explain these two, and then your question. Then okay, I guess I hope. Bye everyone. Thank you for